Well, now, in order to talk about, air with any kind of detailed quantitative understanding of air, we have to think like a chemist. And chemists organize matter, everything that has mass is matter, and everything around us that has mass we would consider to be matter, including, obviously, air. But anyway, chemists organize matter using this basic schematic approach. Matter is everything that has mass, first of all. And a lot of times we talk about, or you have heard about, the different states of matter. Matter can exist as a gas, as a liquid, or as a solid. And we can have changes back and forth between, a liquid going from, a solid going to a liquid, we call that melting. A liquid going to gas, we call that evaporation. A gas turning back into a liquid, we call that condensation. And a liquid turning back into a solid, we call that freezing or solidification. Okay, so these are kind of terms that we're familiar with, and the chemist uses them. We want to be very specific about the mixture that we call air. It's in the form of a gas, all right, mostly. All right, so let's take this one step further. Matter, it can be in these different states, and it can exist as we call either a mixture or as some pure substance. In this box, they just use the word substance. Sometimes when chemists are talking about matter, they say a pure substance. Okay, to be absolutely sure that you are distinguishing that from a mixture. All right. Now, we already said on the previous page that air is a mixture, and there's actually two different types of mixtures. There's homogeneous mixtures or heterogeneous mixtures. Now, if you think of air, well, homogeneous, first of all, I should tell you, is a mixture that no matter where you sample it, you're going to get the same components. Okay, heterogeneous mixtures, it means that the mixture doesn't have the same composition throughout. All right, for example, if you had a nice cup of hot tea that you'd added a half a teaspoon of sugar to and stirred it up, and the sugar completely dissolved, then we would consider that a homogeneous mixture. If you sip it, at the beginning, it tastes pretty much the same as if you sip it in the middle. That's a good indication that the mixture is homogeneous. All the parts of the mixture are the same throughout. Heterogeneous, on the other hand, could be, for example, if you had iced tea that had ice and chunks of lemon and pulp and too much sugar, so that the sugar didn't all dissolve. That's still called a mixture. The mixture is still called tea. It's a tea mixture, but in that case, it would be heterogeneous because the components of the mixture are not evenly mixed. All right, so there's a difference. We can talk about mixtures, but there's different types of mixtures. And homogeneous mixtures are also called solutions. All right, now let's think about air. If you think about air, we've already identified air as a mixture. Do you think that air is a homogeneous mixture or a heterogeneous mixture? Okay. Well, it depends on if you're talking about the air, for example, right around your face right now. Take a deep breath. That air is most likely a homogeneous mixture. Air is a gas, and gas particles move very, very fast. They don't touch each other, and they're in constant motion. And so in this room, for example, all of the gas particles are moving very, very fast, constantly mixing, and they should be a homogeneous solution. If I were to introduce some other gas into this room, say I take a tank of propane and I open it over on the other side of the room, and propane gas starts leaking into the room. Until the time that all of the gas molecules have a chance to mix, that mixture is going to be heterogeneous. Okay, it's not going to take very long, but at the very beginning it's going to be heterogeneous. So even if you have all gas, at a certain point in time you could have a heterogeneous mixture, but normally they're homogeneous. Okay? All right, so mixtures are made of pure substances. All right, and then pure substances can be subdivided further into compounds and elements. We're going to talk about compounds and elements in the next lecture. Today we're going to focus on how we define mixtures.